Let us look at proposition number 11 of Works of Archimedes, specifically book 1 of On the Sphere and Cylinder. The proposition says, if a plane parallel to the axis of a right cylinder cuts the cylinder, the part of the surface of the cylinder cut off by the plane is greater than the area of the parallelogram in which the plane cuts it. So when a plane cuts a right cylinder, its intersection is a parallelogram. So let's name this as A, B, P, Q. Now let's proceed. Let a right cylinder be cut by a plane BAPQ parallel to the axis of the cylinder. The proposition is saying that the surface area of the cylinder cut off is greater than the area of the parallelogram BAPQ. Bisect the base of the cylinder, that is circle ABD at D. Join AD and BD. Draw DR perpendicular to BD or DR parallel to AP or PQ. Join PR and QR. Now here triangle ABD is congruent to triangle PQR, and a right prism with triangular basis is formed. Now parallelogram BDRQ plus parallelogram ADRP is greater than the parallelogram BAPQ. Let G be such that parallelogram BDRQ plus parallelogram ADRP is equal to parallelogram BAPQ plus some area G. Now the area that we choose as G could be greater than the segments of the circle ADB and PQR, or it could be less. So let's take these two cases one by one. Let G be greater than the segments of the circle ADB plus PQR. Arc ADB is greater than the triangle ADB because both arc and the triangle have the same extremities. That is the line AB, and the triangle ADB is inside the arc ADB. So because of which we can say arc ADB is greater than triangle ADB. Now arc PRQ is greater than the triangle PRQ, excluding PQ. Why? Because again, extremities are same and the triangle is inside the arc. Now, lateral surface of the cylinder BDAPRQ plus segments of the circle ADB and PRQ is greater than the parallelogram BDRQ plus parallelogram ADRP. So lateral surface of the cylinder BDAPRQ plus G, that is the segments of the circle ADB plus PQR, is greater than the parallelogram BDRQ plus parallelogram ADR. Now we are substituting segments of the circle ADB plus PRQ with G because this is G is greater than the segments of the circle ADB plus PQR. So the inequality still remains. But parallelogram BDRQ plus parallelogram ADRP is equal to parallelogram BAPQ plus G. So we subtract from both the sides of the inequality G. We are left with lateral surface of the cylinder BDAPRQ is greater than parallelogram BAPQ, which is what we had to prove. That was in this case where G is greater than, or rather the area that we have chosen is greater than the segments of the circle ADB plus PQR. Now let's look at the other case when G is less than segments of the circle ADB plus PQR. Now let me remove this plane so that we don't get distracted with it. Repeatedly bisect arcs BD, AD, PR, and RQ. So C, E, S, T. Join these segments. And we keep repeating this till when? Till the difference between the circle and polygon becomes less than the area that we have chosen. And for simplicity's sake, let them be at CEST. If it is not, then we again have to bisect them and the diagram becomes messy. So now let's join these points. Okay. Now, segments of the circle BC, this small area, plus CD, plus DE, plus EA, plus PS, plus RS, plus RT, plus TQ. Say the sum is M, is less than G. Then surface of the cylinder BCDRTQ, BCDRTQ, plus segments of the circle, these specific BCCD, RT and TQ. Segments of the circle is greater than the parallelogram BCTQ plus CDRT. Again, similarly, surface of the cylinder DEAPSR plus segments of the circle is greater than the parallelogram BESR plus AESP. Now, the segments of the circle with respect to this and segments of the circle with respect to this, if we add it up, then we get M. And when we add these two up, we get the surface of the cylinder BCDEAPSRTQ. So, surface of the cylinder BCDEAPSRTQ plus M is greater than the parallelogram BCTQ plus CDRT plus DESR plus AESP. But the parallelograms BCTQ plus CDRT plus DESR plus AESP is greater than the parallelogram BDRQ plus ADRP. So, which means surface of the cylinder BCDEAPSRTQ plus M is greater than parallelogram BAPQ plus G. Why? Because again, parallelogram BDRQ plus ADRP is parallelogram BAPQ plus some area G. Here comes the tricky part. Since M is less than G, because remember, G is less than segments of the circle ADB plus PQR. But M is the much smaller segments. So M is less than G. So if you look at this, we have this statement that the surface of the cylinder plus M is greater than BAPQ plus G. So if we remove M and G from both the sides, what happens? A smaller magnitude is reduced from the left-hand side and a larger magnitude is removed from the right-hand side. So, which means surface of the cylinder BCDEA PSRTQ is greater than parallelogram BAPQ. That means the lateral surface of the cylinder BCDEA PSRTQ is greater than parallelogram BAPQ, which is what we had to prove again. So that is proposition number 11 of works of Archimedes, specifically book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.